Alright, hello everyone. Welcome to Workshop 2. So in Workshop 1, we went over the anti-spark circuit, how it works, what it does, stuff like that. There's a full video already uploaded on this anti-spark circuit. We also went through like what an electric vehicle is and like how does it work, how to read schematics, stuff like that. So by now, since I went through all this information with you, you should understand how this circuit works. And maybe you don't need to understand it like fully to completely do schematic design, but it'd be good if you did understand some of it so that, when we go into workshop 2, you know the reason why we're putting down the components. I don't think PCB or I don't think schematic design or PCB design need you to understand fully what the components do, but it's really important for you to like kind of have inside your mind like what the general purpose is. All right, cool. So we're going to just jump right into it because I don't really want to stall. This is kind of the overview. What we're going to do today is pretty much go from absolutely nothing or kind of our Falstad simulation, right? So this circuit right here, and we're going to make the circuit on Altium, right? So yeah, in this in this workshop, we're going to pretty much make a circuit and make the schematic, and it'll be ready for pretty much making a PCB. So super exciting, right? We're already getting into it. So first thing I note, this is like all the notes that I'm going to be referencing. So if you're ever lost or need help, you can go to the notes and yeah, this is the video for that. So if you don't have Altium yet, install it right here. You can download it right here. If you have a Mac, you can't really download Altium, unfortunately. You might need to get like something like Parallels, or if you want, you can also just use KiCad and make the circuit with us. But yeah, that's how you get Altium. So hopefully you can. If you don't have Altium, contact me or Demir. And once you open Altium, you'll start getting a screen like this. All right, cool. So let's say you installed Altium, you have everything ready. This is kind of your screen that you have right now. Sorry, let me close this project so I can go with you. Just don't save. So you're on this screen, right? First thing you want to do, obviously, sign it, right? And put in your credentials. Type it, whatever it is, press sign in, right? Now, since you have an invite to Altium, you should see this on the top right that you're part of electromobility. And it's also going to ask you to choose a license. You're going to press choose a license, and you're going to see this Altium Designer Professional license, and you want to use this license. It's pretty much the Altium license the university provides us. Once you press use, it should turn green, which is great. Cool. All right. So now we're connected to the workspace. We're ready to work on it, but we need a project file to start working on it, right? So what you're going to do is go on this link right here, or pretty much search up University of Waterloo project Altium or whatever. I'll put the link in the chat as well, or like in the YouTube description. So sign into Altium, right? Save our account. So you're gonna go to this link right here, University 38.1.365, and you're gonna go and see this project folder right here, right? Now, this is where all the projects of Electrum is stored. So you can see here we have a couple of projects, but there's one that's called Anti-Spark Workshop 2. We're going to click into there because that's what we're going to work on. And you're just going to press the new button, right? So from here, you're going to go new, create project, and you're going to be able to create your project. So I kind of want to see this naming convention. First name, Anti-Spark, because that's the project we're working on. Project names like Bakfeed, Stealth Bike, whatever you're working on, and then the term, so winter 24. All right, cool. So after that, you want to press create. So mine is going to be Sherwin Anti-Spark. I'm carbon fiber skateboard. So all right, carbon fiber skateboard. All right, cool. So press create. I already created this, so I'm not gonna press create again, but you press create, and then you're actually going to be able to view this in Altium. So what you're gonna go to is go to these three dots right here. Click onto this and press open project. So once you press open project, you can see all the projects that have been created, right? And ours is the Sherwin Anti-Spark Carbon Fiber Winter 2024. So you're just going to press open, so that opens your project. And you can see that it's open on the side right here. Cool. So as of right now, I have no source documents. This is not a real document. Just remove that. But it says no documents added for you. So what you're going to do is right click, add to project, and add a schematic, right? So what a schematic is pretty much going to tell us like the blueprint of how we're going to wire everything up, right? The computer doesn't know how we want to wire things up specifically, so we need to tell it. That's what the schematic does, right? since we make our schematic, it'll transfer directly to our PCB design, which is our real live view of how the circuit is combined in real life, right? So first we're going to start with the schematic. You're going to see that you have the sheet right here. And it's pretty much like a grid, and there's a bunch of buttons you can press. So the first ones that you're going to do is this little text box right here, text string. And I want you to fill in these values, the title, the number, or sorry, the revision, and who it's drawn by. Right, so for me, right, I'm going to click on this once, which will let me edit it. Click on it once, there we go. I'm going to title this anti-spark, sure one, because, or sorry, anti-spark circuit, because that's what I'm making. And maybe putting circuit's a bit redundant. And then revision, this is my version 1, and this is drawn by me. My name is Sherwin. Hello, for those of you who don't know me, my name is Sherwin Chu. Okay, anyways. Alright, cool. So now we can start our schematic, alright? So the first thing that you want to be really familiar with is this top bar, right? You can choose all your components here and stuff like that. So one of these buttons is called place part, and one of them is also called like place your power port. So if we look at our FileStat schematic, and I really encourage you to start from this FileStat schematic, you'll see we have our ground here, and we also have a battery that acts as a voltage source, right? So at this top bar, we have this voltage source, voltage. So here I'm going to place down my ground. And if you right click on this power plane, you can put down a bunch of power ports. For me, I'm just going to use VCC as like my 42 volts, right? Now I want to start wiring things up, right? And usually I like going from left to right, like most complex to least complex, right? So here is like, oh, some resistors. Here's a resistor here. So I can place like all those resistors down. That's cool. Note that here I also disconnected the load, right? If you think about real life, our load isn't instantly connected to our anti-spark. We have to connect that later on. So these two will be hanging and will connect to our load. All right, so how do we place components? If you go to this yellow part right here, it says place part. We have a section here called resistor 0805. And you can put down your components. So we're going to use 1.2 mil instead of 1.1 mil. Cool. You can, there's two ways of doing this, drag and drop. So right here, I'm dragging and dropping. And I'm pressing spacebar to rotate it. You can also click it once, and then it'll give you that component. I prefer drag and drop, but for some components, you might want to just click it, and I'll show you that case later. So here's my 1K, and that goes in between this. Cool. So now I put all the resistors I need, and I'm going to put my capacitors now. So I can go components, and I can press this top bar and go into capacitors. We're going to use a 1 microfarad capacitor, so I'm just going to drag this right here. Cool. Now notice that these are actually missing some values, right? So what happens if they're missing values? We want to edit the properties of this. So for any component, you can double click it and edit the properties of that component. And if you notice the comment here, it's, you know, non-visible. So we want to make that visible. We totally did that on purpose, so you can look at the properties, right? So I'm going to go through all of these and make them non-visible. Or sorry, visible. Ooh, we can see it now. So you can see the labels are kind of messed up. Just drag it and press spacebar 4 times, and then that'll put it in like the proper place. Okay, cool. This capacitor is here, and this can go right here. All right, cool. You have all the components. So now we have to wire it up. And if we look at this diagram, right, there's like a wire here, it connects all these components. I'm just going to wire these first, and then I'll add the transistor and the diode later because it's a bit more complex. So here you can press the Control W command like on your laptop, and that gives you the wire view. That's really convenient because the wire is like the most important tool that you're going to use. Or you can also just place the wire by pressing from that dialog there, whatever floats your boat. So here I'm just going to wire everything up. And you kind of want to make it look nice, you know, don't make it messy. Try to not cross the wires as much as possible. Just make it readable, right? No one likes a non-readable schematic. Okay, cool. That looks pretty good. Okay, we also have this top bar here that just goes straight across. Cool. And yeah, that's pretty much it. All right, cool. What else do we need? Well, we also need our diode, right? So for this exercise, we chose like what components to do for you already. But I want you to, after you place down your component, look at the data sheet of these components to see why we chose these components in the first place, right? So from last workshop, I kind of talked about like the gate and like what voltage it turns on to, and that's the purpose of the Zener diode. If you double click on the Zener diode, scroll all the way down, you can see that the part choice has a data sheet attached to it. So I can actually look at the data sheet for the Zener diode, right? Which is really cool. And we can look at all the specs for it. So I want you to look at the specs and see like why we chose this. I think the most important one is 12 volts is its reverse bias, which is the reason why we chose it. So that's going to pretty much clamp the gate to 12 volts for the MOSFETs. All right, cool. Now this goes out and we're going to have MOSFETs. So let's go to our transistors. And boom, I can place down my transistors. Now I need 3 of them. So I can copy and paste it, you know, just like how you would copy paste like a text. There we go. And I'm going to wire the gates to it. So maybe in this case, I need a little bit more space. But I'm going to click here once, click here once, click here once. I'm going to wire this to this, and this to this. And maybe this can be my ground. So it needs to be a little bit lower, but that's fine. So let's say I want to just keep this wire here. I can just double click. So I can click here to pivot. One here, one here, one here. Boom, I have my wire everywhere. And I just move my ground down and connect that all up. Sick. Now this is connected to the top of the MOSFETs right here. Yeah, if I'm not mistaken. Yep, it is. And then this wire just comes out. Sorry, I'm also using a trackpad, so everything's kind of a bit slower. And then we have our outside here. All right, cool. So we're almost done our circuit already. All right, this is a pretty relatively like simple circuit. Doesn't take much, right? And this is where I'm going to stop us, right? So like the switch is kind of really complex, right? That's why I kind of ignored it at the beginning. We want to go from simplest to most complex. And we kind of like are missing some wires for the load, right? So this is a point where we stop and think about our circuit in like real life. How are we actually connecting VCC and ground? Because it's not just going to be like, oh, I say VCC is here, now I can connect it, right? We need a physical connector that attaches this, right? In our case, most of our batteries use a male XT60 connector that connects to the anti-spark. After that, the anti-spark is going to connect to whatever ESC motor controller that we're using, right? So we're going to go to components, connectors, and use the female connector to connect to the the male connector to connect to the battery. So if you think of our battery, it uses a female connector so the prongs can't touch each other so it doesn't blow up, right? So this male connector can just connect to VCC of the battery. So here I'm just going to put VCC. And this negative is going to connect to our ground of our battery. So here I'm going to put ground. Notice I like copying and pasting VCC and ground instead of going up here. It doesn't really matter what you do. So now we're going to have our output, right? And on our output side, we don't want to just route VCC and ground to the output because that way, like, you know, we're just shorting the VCC and ground. It's just going to go through. There's no point in even making this anti-spark, right? And if you notice, our load is connected to this wire and this wire, right? So what we could do is put this wire like to 1 and this wire to 2 and wire it like this. But it's a bit like messy and I like, can't really see of a good way of like wiring that up. So if we have like a situation where the wires are like in a bad position, we can use something called net labels. So if you go to the wire and press net label, what this does is any net label with the same name as each other will act like a short circuit or pretty much like a virtual wire that's connected, right? So let's say, for example, I name this out plus and out negative, and I put out plus right here and out negative right here. What this will do is like virtually connect these pins. So this 2 is connected to this out negative, and this 1 is connected to this out positive. So I don't need to put any wires. Everything is a little bit more clean, and everything should be connected. Okay, cool. Let's move this wire out a bit. Put this here, and for consistency, I'll put out negative here. You also want to make sure on your net label, this red cross shows up, because that means it's connected, right? You don't want anything not connected. So for the shield on the female pin, we actually don't want anything to be connected. So we can right click this information and press generic no ERC. What that specifies is there's no connection on this shield. All right, cool. So Altium does like cool stuff where it like checks to make sure that like all your connections are necessary and stuff like that. And if there's anything unconnected, it'll tell you to reconnect it, right? All right, cool. So that's pretty good for our circuit. The last thing we're missing is our switch, of course, right? So for our switch, many of the switches that we use, right, we don't want to put it directly on our PCB. We probably want a connector that goes out to a switch so that we can put it like wherever we want, right? We don't want it to just like be floating everywhere. So instead, if you look at this example for a switch, it has like 4 wires, and 2 of the wires are used for LEDs. On the switch, you see this blue circle, and 2 of the wires is to like actually toggle it on and off. So if you go into components, we actually made a component for us. And in this case, you want to double click because this is a multi-component or multi-schematic symbol component, right? So you see here, there's a J question mark A and a J question mark B, and with pins 1 and 2, right? So for the switch, we're going to have pins 1, connect the switch to ground, right? Which is what this is doing in our phosphatide circuit, right? This connects to ground or it doesn't connect to ground. In fire 3, it just lights up an LED. So what I'm going to have is connected to the out negative and out positive of this anti-spark circuit and connect to this connector. Now this connector is also kind of in the wrong order. So if you double click it and go all the way down and press mirrored, it's going to mirror your circuit so that, you know, you can have 3 and 4 up here. So I'm going to route out positive to 3 right here and out negative to 4. And we can connect our LED. If we think about something that we're missing, we're also missing a resistor, right? We need to connect a resistor for our LED so it doesn't blow up. Our voltage is pretty high. It'll be anywhere between like 30 volts to 45 volts. So let's make sure we add an appropriate resistor to that. With this filter, let's put a 10K resistor. Boom and boom. Cool. So we're pretty much almost on our circuit, right? There's just one last thing that you always want to think about when you're designing any circuit, and it's protection, right? So we want to make sure that, like, in the case of failure, like let's say our motor controller dies, we don't just pump thousands of or hundreds of amps into our motor controller and everything gets caught on fire, right? In this case, what prevents like really huge inrushes of current is a fuse, right? So we should use a fuse. So go to fuses and use this fuse holder, right? We're going to use this to hold the fuse. I'm going to delete this wire and put the fuse in between. This way, right, if too much current goes through or is trying to go through, it's going to stop it by blowing up the fuse. Cool beans. That's almost pretty much it. So the last thing we're going to do is annotate our schematic. If you look, there's a bunch of question marks on all our components. You just want to go Tools, Annotation, Annotate Schematics. Instead of across and then down, go to down, then across, which is a nicer pattern for our case. Press Update Changes List. Press OK. Press Accept Changes. Press Execute Changes. And you should see all these question or check marks. And that will annotate our schematic. So that's pretty much it. That's the schematic done. I would very highly recommend double checking and making sure everything's good. Once you're done your schematic, press Control S or save and save your sheet, right? And also save to server. So make sure that it's saved to server so people can see it, right? I really encourage you to go into one of these schematics and really review it, right? So like take a look at it. So we go to projects. Let's go to Megan's schematic because Megan will judge, right? And we can actually see the schematic from the Altium view. It's pretty nice, right? And it'll be a pretty similar schematic. And I think this is really important because as much as we love like making this type of stuff, we have to also review it, right? So already I see some problems, right? So here in this view, I can place some comments. So here I'm going to place a comment right here. Like this should not be attached, right? Because now your source current is attached to the gate. Not good. So I'm going to put it right here. Source is shorted to your gate pin. This is not correct. Please separate the pins. The dot denotes a junction, so it's connected together. Not good. Pretty clear comment. Very short, concise, and and I can move it so that like, it's right on top of the pin. And hopefully she can fix it for both of them. Right? What issues do I see? Well, this is connected to the out negative. Yeah, I guess that's fine. You can technically do that, but ideally we want this to be connected to the out positive, right? So that the LED can always be on if the anti-spark is on. Yeah, but that should be fine as well. Whatever you want. Here, she's missing the ERC checks. Right. So I'm gonna place another comment, missing ERC. So go find your friend's schematic, put comments on it, make sure that everything is good, and make sure that yours is good too. What else? Well, here there's a bunch of she put a wire through the resistor, so now the resistor is going to be completely ignored because it's replaced with this wire. So I need to add a comment here. Oh, darn it, I clicked on here. Put a comment here. I should place comment. Wire. There's a wire on top of the resistor. This will bypass the resistor in the actual PCB design. Please get rid of that wire. Cool. Boom. So we got a bunch of comments. Everything else, like this is also improper, right? As we know, we want to... Actually, wait. No, this is for the switch. Okay, actually, that's good. Never mind. I take that back. Alright, cool. I put 3 comments, good enough, but you want to do that too. That's pretty much it for this workshop. So make sure everything's annotated. You got your schematic done. Get your friend to review your schematic. And next workshop, we're going to be making a PCB. Yep. That's pretty much it. Oh, 20 minutes. Sick. I'm fast with it. If you need to watch me slower speed, you can. I was just trying to like go through it. But that's pretty much all I have for you. Thanks for attending. Next time we're going to design the PCB. If you have any questions, please ask me. But yeah, I pretty much showed you how to make a schematic from scratch, and that's pretty sick. Yeah, there's nothing else I have to say. Just make sure you save it to the server. Goodbye for now. See you later.